watching this video. So in this video I'll be doing question 10 of May, June 2021, question paper mathematics paper 1. And this looks like cubic functions plus a mixture of application of calculus. So let's go. The graph of f has two turning points. So this graph of f here have two turning points. Where you are given f to be equal to this thing here. The following information about f is also given. You are given this information about f. You are told that f at 2 is equal to 0. You are told f at 2 is equal to 0, which means if you substitute 2 there, your answer is 0. The x-axis is a tangent to the graph of f at x equal to -1. So the x-axis is the tangent to a graph f at x is equal to -1. Okay. You are told that the f prime at 1 is equal to 0, which means the derivative, or maybe the gradient at x is equal to 1 is 0. Right? And you are told that the derivative, or the gradient, because f prime represents the gradient, you are told that the gradient at half is greater than 0. So let's try to understand what this thing means. So you are told that you are given the cubic function that have two turning points. Okay, you get that. You are told that f at 2 is equal to 0, which means if you substitute your 2 here, your answer will be 0. What does that mean? Which means this is the x-intercept, this one. Because you know, for your x-intercept, your y is 0. So we have our y is 0 and x is equal to 2, which is 2 is our x-intercept. Right? So if we're drawing this graph here, if we're drawing our graph, our cubic function here, which they want us to do, so we have x, y, and x, right? So you're told that at x equal to 2, you have your x-intercept. So if your 2 is here, this is your x-intercept. Your graph intercept the x-axis there, right? You're done with this part. It's the x-intercept, which is it will cut through the x-axis at x equal to 2. Let's go to this one. So for this one here, you are told that the x-axis are a tangent to your graph, right? The x-axis are horizontal like this, right? If they are a tangent to your graph, it's either at x equal to -1. So here at x equal to -1, your graph is turning there. It's either turning like this or turning like that. Because since the cubic function, and you're told that your x-axis are a tangent at x equal to -1 on our graph f, it means your x-axis at x equal to -1 touches your graph at the turning point. That's what that thing means. Because for horizontal x-axis to be a tangent to our graph, that have to be a turning point. Okay, so this is what the situation that we have there. It's either it's like this or like that, but we're not sure which direction it is. So we have this part that we have a turning point at x equal to -1. So let's go to the third one. On the third one, you are told that the gradient at x equal to -1 at x equal to 1 is 0, which means x equal to 1 is here, right? So along this line, somewhere, if the gradient is 0, which means we have the turning point there. So we have a turning point somewhere along this line. I'm not sure which direction it's turning. I'll turn this way or that way or that way. But along this line, we have a turning point there, along x equal to 1. That's what they're telling us. But we're not sure where this thing of ours is turning. So we don't really know. Right? What else do we have? So we have that the gradient at 1/2. The gradient at 1/2 is greater than 0, it's positive. So where is 1/2? So 1/2 is somewhere here, right? So somewhere along this line, our graph is what? Our graph this gives us the gradient at a point, which means our graph had a positive gradient somewhere on that line or somewhere at that point, which means wherever that position might be, our graph is increasing in this point. So in this point, our graph is increasing because in order to have a positive gradient, because f prime gives us a gradient at a point. So if f prime is positive, which means your graph is increasing, right? It means your graph is increasing. So at 1/2, your graph is increasing. So you know with the cubic function, the cubic function can be like this, or it can be like this. Can have any of the two shapes, right? So we have a turning point here, right? And you find that in between, your graph was increasing. What that means is you have a turning point, something like this, and your graph was increasing in between. Because you know this is the turning point, another turning point is here, at this point here. So this is your -1, and you know that will be your 1. So if your gradient is greater than 0 in between, which means that between this part, between these turning points, your graph was increasing. So I'll say your graph was something like this. I'll say your graph was increasing. I'll say your graph was increasing between the 2 points and turned there. Because here the graph have a positive gradient here. So x is equal to 1/2f. The gradient of 1/2 is positive, as you can see here. So you have a turning point here, and it goes down there. And then it turns up here, goes all the way up. So I'll say your f is something like this. So if you look at it, you have the x-intercept at 0, at 2 is x-intercept at 2. X is a tangent at x equal to -1. X is a tangent at x equal to -1 because here, there a tangent, here's a tangent here. Right? And then you're told that the gradient is 0 at x equal to 1. Gradient is 0 at x equal to 1, which means that is a turning point. Done. And then you're told that your gradient was positive, it's 1/2. The gradient is positive at 1/2. So your graph should look something like this, or similar to this. So yeah, we're done with this one. So we're going to do, so just say without the equation f, use this information to sketch the graph of f to only indicating the x coordinates of the x-intercepts. Here's the other one, here's the other one, and the turning points, here's the other one, there's another one. It should be something like this. So I'm done with this one. We're going to go to 10.2. So I'm going to clean the board and then draw this thing, try to draw it at least, then try to answer the questions that follow. So let's go. So now I've tried to draw the diagram here, but I'll show the more nicer one so that you can see, you know. Okay. 10.2. O is the center of a semicircle passing through A, B, C, and D. The radius of the semicircle is x minus x squared units, for x is between 0 and 1. So the radius of your circle outside of a semicircle is this one, where x is between 0 and 1. Triangle AOB. The triangle AOB is right angled at O. So this triangle AOB is a right angle, and the angle 90-degree angles at O. So let me try to read this again. 10.2. O is the center of a semicircle passing through A, B, C, and D. The radius of the semicircle is x minus x squared. And the radius of the semicircle is x minus x squared units, for x is between 0 and 1. Triangle AOB is centered or is right angled at O. So 10.1. Show that the area of the shaded part is given by this. Okay. So here is what is happening. So you are given this half a circle here, right? This half a circle passes through A, B, C, and D. So here is half a circle, semicircle. So what are you told? So you are told that the radius of this half a circle is this, which is our radius, which is from here to here, is our radius, which is equal to what? X minus x squared, for x is between 0 and 1. Same as this one. From here to there is also r. This is the radius. So they are telling you that AOB is a right angle triangle. AOB is a right angle triangle with a 90-degree angle at O. Right? So they wanted to show that the area of the shaded part, which is that part, that segment there, is given by this thing here. So how do we do this? First thing that you should do, you should calculate the area. You should know how to calculate the area of a circle. The area of a circle is equal to what? It's equal to pi r squared. That's the area of a circle. So you know pi r is your radius. So which means the area of a circle will be pi r. What is your radius? The radius is r, which is x minus x squared. So pi r squared. So your r was this squared. Just substitute your r there on our formula. So let's simplify this. So the area of a full circle is pi, multiply this bracket out, x minus x squared, x minus x squared. Multiply this bracket out. So pi, so x squared minus 2x cubed, right? Plus x to the power 4. So this is the area of a full circle, right? But now what we want the area of this shaded region here, of the shaded region. We want the area of the shaded region here, which is this part, this small part there. So what do we do? So we have the area of a full circle now. What we can do is, okay, since we have the area of a full circle, what we can try to find is the area of this part here, of this part of our circle. This part. We can try to find the area of this part. So this part is a quarter of a circle, because you can see that you have a 90 degrees here. So your circle, your full circle gives you 60 degrees, right? So half a circle gives you 180. And so this one here is 90 degrees. So that is a quarter of a circle. So the area of this part, which is this part of a circle, is equal to what? Area of AOB, not the triangle, this segment here, or this sector here, the area of the entire sector, all this part here, including the shaded and unshaded part, will be a quarter, which means 1/4 of the area of a circle, of this area here. Pi into x squared minus 2x cubed plus x to the power 4. So the area of this entire portion of our circle is equal to pi over 4 into x squared minus 2x cubed plus x squared, x to the power 4. So this area here is the area of this entire region. It's the area of AOB. It's the area for that entire segment, the shaded and the unshaded one. So now, since we have that area, the area that we want is this one here. So what we can do, we can, from this area, we can remove the area of a set of this triangle here. So this area is for the entire segment, which is the black shaded part and the red shaded part. But we want the area of the red shaded part. So to get the area of the red shaded part, let's remove the area of the black shaded part. So the black shaded part is the triangle. So the area of triangle AOB is equal to half base times perpendicular height, right? So half our base, what is our base? Say 6 radius here, x1. Okay, so it will be this length here, which is our radius. What is our radius? It's x minus x squared times the perpendicular height. What is our perpendicular side? Which is this side here. This side is the radius, right? From the center of the circle to the circumference, and this one is the radius as well. So you have the height will be the same as well. So the area of triangle AOB is equal to half of what? You will have half of x squared minus 2x cubed plus x to the 4. So this is the area of the black shaded part, and that is the area of the whole part, which is the red shaded and the black shaded. But we want the area of the red shaded part, so we're going to remove from this all area of the entire area, we're going to remove the area of the black part, which is this. So the area of red shaded is equal to the area of the entire part, which is pi over 4 into x minus x squared minus 2x cubed plus x to the power 4 minus the area of the black shaded part, so that we are only left with that. The area of the black shaded part is what? It's 1 over 2 into, which is this one, 2x squared minus 2x cubed plus x to the power 4. Right, so this is equal to pi over 4 to x squared minus 2x cubed plus x to the power 4, this part, minus 1 over 2 into x squared minus 2x cubed plus x to the power 4. Then we take out the common factor, which is this. So common factor is x squared plus minus 2x cubed plus x to the power 4 into pi over 4 minus 1 over 2. Right? So we simplify this. The area of red shaded part is equal to this thing, which is x squared minus 2x cubed plus x to the power 4 times this. What is this? 1 over 4. What do you do? It's pi minus 2. Done. We have shown that the area of that small shaded part is this, which is that. We're done. So we'll go to the next one. 10.2.2. So these ones are nice, right? Because even if you don't know how to prove this thing, so they asked you to show that is this, the area is given by this. On the next question, you can use that information that you have. So let's go to the next one. So determine the values of x for which, okay, now determine the values of x for which the shaded area will be a maximum. They wanted to find the values of x, right, for which this thing will be a maximum. So the area of the shaded part is given by pi minus 2 over 4, right? So into x squared minus 2x cubed plus x to the power of 4. So now to find your maximum area, we derive this thing of ours, equate it to 0, and find your x. That's all you do. That's all you do. So find a prime as a function of x is equal to, leave this constant out here, over 4. Derive what is in here. What is the derivative of this? It's 2x minus derivative of that, 6x squared. Derivative of that, plus 4 x cubed. Right? That's the derivative of that guy here. Then what you do, you equate the derivative to 0. 0 here is equal to pi minus 2 over 4 to 2x minus 6x squared plus 4x cubed. Then divide by this both sides, divide by pi minus 2 over 4, divide by pi over 2, pi minus 2 over 4. This and that go away, the sign is 0, is equal to 2x minus 6x squared plus 4x cubed. Then take out the common factor, which is x. 0 is equal to x. So we have 2 minus 6x plus I could have taken this out as a common factor. So let's take 2x as a common factor, right? Let's take 2x as a common factor. So what we have, 0 is equal to 2x common factor. So we have 1 minus 3x plus 2x squared, right? So for this, you have a product of two things equal to 0, which is this part is 0, that part is 0. 2x equal to 0, which should mean x equal to 0, or your 1 minus 3x plus 2x squared is equal to 0. This is question 1 stuff. Question 1 stuff, you know how to solve these. So 2x squared minus 3x plus 1 is equal to 0. How do you go about this? So 2x, x, 1, 1, minus, this time this 2x squared, this time this is 1, this time that, it's, this time that, it's minus 2x, minus x, minus 3. So these are your factors, these two. You can use the quadratic equation if you don't know how to factorize. So we have 2x minus 1 and x minus 1 is equal to 0. Therefore, your x is equal to 1 over 2, or your x is equal to 1. But we were told that our x values are between 0 and 1, which means 1 over 2 is between 0 and 1. And 1 is not, because the endpoints are excluded, right? So that is the value of x, which will give us the maximum area. And we're done with this question. I hope it does make sense, and I hope it's clear. So this x value will give you the maximum area of that shaded region. So yeah, thank you.